Guys, welcome back on my channel. In this video I want to show you how to make these procedural lips, and next I'm going to show you how to link the output attributes of the workflow with the sound file. So let's get started. I'm working with Blender version 4.0.2. First of all, we are going to use a simple mesh, a simple plane, to create our geometry nodes setup. So let's create it. Shift A, mesh, plane, go to the plus button, general geometry nodes, and press the new button. Now, the project contains two parts. One is the upper lip and the bottom lip. So press 1 to go to the front orthographic view. And the first step is to create the upper lip. Next, the bottom lip. Third part will be create some 3D displacement of the lips. And the last part, the linking with the sound file to animate the output attributes of our network. First, enable the snap tool with this button here. Next, we are going to create a curve line to define the horizontal line to create the lips. Let's create some attributes because we will use them a lot. So first we need an input attribute as the resolution of our lips. That is an integer number from 0, default 2, for example, and this is a single value, and we are going to use the same value of the resolution for the upper and the bottom part. So now the curve line is here. We can set minus 1000 and 1000 millimeters, for example, to have the negative and positive direction, so we can link directly the curve line in the geometry. Here we needed to set 1000 here. Okay, perfect. Now we can resample this curve using this resolution, and now we need to offset these points. We can set 64, for example, and now we need to set the position, the new position for this resampled curve, and offset with a combine XYZ node, and we need to link the Z to a noise texture like this. So in this moment we need other float value to decide what is the scale, the amplitude of this noise texture, and the seed in the space to use this vector. So to do this we need to create an upper frequency float value. This is a single value. Let's duplicate it. Upper phase and upper amplitude. We can duplicate the group input, change the type of the noise texture to 4D to have a W value, to have a phase shifting of this frequency, the scale, and link the frequency in the scale and the phase in the W. Now we need to multiply the factor with the amplitude to have more or less amplitude here for the offset, linking this upper amplitude in the multiply. We can press H to collapse, and if I link this multiply to the Z, you can see this effect here. I set 0 for the detail and 1 or 0 for the roughness. Let's add some values here for the upper frequency, 4.5 for example, 0.4 and 0.5 for the amplitude. Now we need to decrease the offset going to the start point and the end point. So to do this, we can use this output and multiply this by a sine mathematical function using a map range where we can link this value to a separated XYZ linking the X of what? Of the actual position of each point. So the workflow works in this way. I take the position, I separate it in XYZ, I take the X, and you can see because I have here minus 1000 millimeters, so without the unit measure I have minus 1. And here I have 1, so I can set here a range from minus 1 and 1 and transform this range of numbers in the x-axis from 0 to pi. Why pi? Because the sine is like this. I want this shape, and because the sine of 0 is 0 and the sine of 2 pi is 0 and the sine of pi is 0, I want to have this bell shape, so this part of the sine, and to get this I needed to transform the range from minus 1 and 1 to a range between 0 and pi. And now I can link this sine result to this result of the multiply of the noise texture, and link this multiply to the z, and voila. Now I can increase or decrease the amplitude, increase or decrease the frequency, and change the phase as I want, and increase the resolution to have a more smoothed effect between the points. We can press H to discombine, move this set position. We can select these nodes, Ctrl J F2, noise, upper part, press H, select these nodes, Ctrl J F2, influence. Now we need to create from this curve the entire mesh of the upper part, and to do this we need to convert this curve to mesh like this. And I remember you to link directly this output of this node to the group output. You can easily press Shift Alt and click on the node you want to link in the group output. Now, because we are going to use the maximum z value of each point as the depth in the displacement effect on the y-axis, I need to save this information for each point and use them next in the workflow. So to do this, we need to store name attribute. The name will be max z, and for this I get the current position, separate in each component, and save the z value here. Press H to collapse, and now I can select all these nodes, Ctrl J to save max z, and I will use this max z to create the displacement on the y-axis for the points that will be on this axis at the height of 0. So for this we need to extrude these edges and move these edges on the x-axis to have the entire shape of the upper part. And for this I can use an extrude mesh, set the offset scale to 0, Shift Alt and click to see the result. I want to extrude the edges and offset these edges where? On the x-axis. So to do this we can add a set position here and get the current position of the points, separate each element H, add a combine XYZ, link the original X and Y and not the Z. We leave the Z to 0 because we want to have this final position, but for what? For only the top, so the new edges of the extrude mesh, leaving the other as they are. So linking these, you can see the effect is this, and if I press Shift Z, you can see the new side edges created. I can press H to collapse, select all these nodes, Ctrl J, F2, create the physical shape. Now we can create the same part for the bottom side, and to do this we can easily select all these nodes, Shift D to duplicate it, and we can rename the noise part to noise bottom part. Now we need another multiply node to multiply this output of the sine and this multiply result to link this value in the z-axis of the bottom part. But now I need to create the same attributes for the bottom part, so we need to take this upper frequency, duplicate it, call it lower frequency, so I can rename this section to lower part, move it down, duplicate the phase, lower phase, and move it down, and duplicate the amplitude, lower amplitude, and move it down, and link this attribute here in the scale, in the amplitude, and in the phase, leaving the amplitude as the last input attributes. Next we can join them together, these two output, pressing Shift, Ctrl and right drag between these two nodes, G to move. Let's add some attribute here, -10, 0.5 and -1. This is the result, but in this case, in the lower part, I don't want this effect like the upper side. I want to have a snapping result, and to create this effect, I need to go here where I have the noise lower part output, and here in the multiply, insert a snap node and link this result in the multiply of the sine, and this will give us this effect. So initially I have the snap of this noise output, and next I have the multiply of the result by this sign, and this creates this snapped bell effect. So now I can decrease, for example, this effect with a positive or negative snap, is my choice, and increasing or decreasing the lower frequency, you can increase or decrease this snapping effect. I can move these nodes a little bit like this. Now let's dive into the 3D effect or the displacement effect, and to do this we need to go here and add a merge by distance, because we need to merge all these points here in the middle. And remember, we have here the saved value of the max z for these points and for these points. Before to create the 3D displacement of the shape, we can save another information, that is the z factor. So a value from 0 to 1 from each point to the z of this point here, or from 0 to 1 between this point and this point here, to use in the shading editor. We can call this the z factor. And how we can calculate it? So we know that here we have points that have the z equals 0 and the other not. So we can get the current position, separate the x, y and z, and ask if the z is equal to 0, link this in a switch to have in the output what value? A float value of 1 if the z is equal to 0, or 0, and link this output here. And in this way I can have here 1, here 1, and here 0. And next, when we are going to subdivide the mesh, Blender will mix this value from 0 to 1, making the intermediate values. Press H, also for these. Now we can select all these nodes, press Ctrl G, F2, save Z factor. Now let's create the displacement effect before subdivide the mesh, and to do this we can link these to a set position to make the correct offset of what? Of only the point that are on the x-axis, so this point. So this point are these. Get the current position, separate in the xyz, and if the z is equal to 0, I want to move only this selection of points. So for these points here, I want to offset by what? By the name attribute, selecting these here in the max z, linking these in a combine xyz on the y value, and linking these to the offset. And why this works? Because when we saved the z information on the original points and then we extruded these edges here on the x-axis, we allowed Blender to copy all the attributes added on these points to the new points shifted on the x-axis for free. In fact, if you look the vertices in the spreadsheet, all the points here has a max z and no one has the value of 0 until the start and the end point. Now if I press Shift Alt and click, you can see this result, and if I press Shift Z you can see these. Now here we have a blending value from the upper Z and the lower Z here in the middle, because the Blender needs to merge the same max Z from this point and this point when we merged them here in this point. Okay, so if you look in detail these shifting on the Y, you can see as the result of the Y shifting here, we have the mixing of the max Z of the upper and the lower point. So for example, this point here, as you can see from the top view, this point is the result from the mixing of the Z value between this point and this point. And because the mixing value of these points is a negative number, you can see I have the shifting on the negative direction of the Y. So if you don't want to have these shifting, but you want always a positive shifting on the Y direction, you need to add here an absolute node and link these to the Y, and this is the final result. So I always have a positive shifting based by the mixing value of the positive and the negative Z of these points. It's your choice. In this example and in the file that you can download from my Gumroad page, you will not find the absolute node. I can press H, select all these nodes, Ctrl J F2, depth, press 1. Now I can subdivide the surface 3 times to have more detail. We can add here a new input attribute for the material that we want to assign to our mesh. We can add asset material, material node, add another time the group input and link the material to the socket, and link here a set shade smooth to have a smoothed geometry. But you can see there is a problem, there is an issue. You can see in this example the subdivision surface doesn't work correctly. Why this happens? Because the bottom faces are pointing on the opposite direction of the normal of the upper faces. So if I enable in this case the face orientation, you can see these faces are pointing the normal in this direction, so the negative y, and the bottom part to the other direction of the y-axis. So to fix this problem we need to go here in the bottom part to the created physical shape, and before joining them together, these two meshes, we need to add here a flip face and link this to this join geometry. Drop with the Ctrl and right drag this connection, and voila! Now we have a smoothed subdivision surface, and we can go here to see the result and turn off the face orientation, and now is more clear the result. And that's it. This is the final mesh. Now we can set a material for our mesh to create the effect of the intro video. So to do this we can easily add a new material, lips, go in the shading editor, focus on this shape, and we can take the attribute of the Z factor that goes from 0 to 1 from these points to all the Z position of each point, and if I press Shift Ctrl and click few times to see the result of the factor, you can see the result selecting here the material of lips. Okay, you see the opposite value that I want to set, so in the geometry nodes we can go in the save Z factor here and set 1 for the false and 0 for the true. In this way I can flip these values from 0 to 1 is what we want, and I can link these to a color ramp and set some values like this. For this I want to have a more purple color like this, switch this, leave the white to the end, link this base color here in the principal BSDF, Shift Ctrl and click, and you can see the similar effect of the intro. We can duplicate these, link the same factor to this factor, select this value, set to 0, and link this color to the emission, and use in the middle a math object to multiply these result by 4 or 5 to have more strength in the emission socket. We can set this to 0.7, decrease a little bit the roughness, and this is the final result. Now last part, link these attributes with a sound file. So I have a sound file, the same used for the intro. I can go to the layout, press the button to see the preview, select the object, press Shift A to add, for example, an empty, because for the sound we can use some of these location to drive the attribute of our lips. So we are going to link the amplitude of a particular bands of frequencies of our sound file to one of the axes of this empty. So I usually do it on the Z axis because it's more cool maybe. And to do this we need to add a keyframe on the attribute we want to link to the amplitude of the sound, going on the attribute and pressing right button, insert a single keyframe. I am in the frame 1, so now I need to go to the graph editor. I increase a little bit this space, select the channel and select the attribute we need, go to the channel menu and select sound to samples. Now we can select our track, select the lower and the highest frequency we want to extract. So from 150 to 300, we can adjust the attack time and release time to have a smoothed curve while the increasing of the amplitude and the release time, so the smoothness of the decreasing values of the amplitude. So I typically set 0.2 and 0.2, for example, leave the other attribute as is and click sound to samples. And now in the graph editor, if I press home, you can see these lines here. If I zoom, you can see the correct sound amplitude. I can zoom in a little bit. Now I can click with the right button here on the Z attribute of the empty, copy these as a new driver, click our object and going to the upper frequency, right button and paste driver. And now if I press space, you can see the changing of the frequency based by the Z of the empty, but the effect is very small. So if we want to increase this effect, we can right click on the upper frequency, go to edit driver, instead of average value select scripted expressions, and here for the location got from the allocations of the empty object, multiply this value by, for example, 40. And now if I go to the first frame and press play, you can see the increasing of the effect, and you can manipulate this driver if you want to increase or decrease the effect as you want, like this, for example. In the meantime, with this effect, if we want to maintain a shifting of this effect here, you can easily add to this edit driver a standard value, so 3 is too much, so 1, for example, and use this phase to move a little bit while the animation. So instead of creating a keyframe on the graph editor, we can select this value and set hash frame divided by frame per second. And if I play, you can see while the animation I have the effect of the frequency, but I have also the effect of the shifting of the phrase. And to see better the result, I go to edit of the frequency and decrease a little bit the value multiplied by the frequency, like this, and you can see this effect here. You can repeat this process for the bottom part using another empty or using another socket of the same empty to drive the lower frequency or the phase or the amplitude or whatever you want. And this was the tutorial. Thank you guys for watching this video. I hope you learned something from it. You can download this project from my Gumroad page and you will find in the file the same result of the intro video with also the sound file inside. If you like my work, please subscribe to my channel, check like, don't forget to check the bell icon to get all the notification of my new videos, and see you to the next tutorial. Bye!